Hello everyone. This is the CBEST Computation and Numerical Relationships workshop. This was a live workshop at the University of Laverne done over Zoom on the 13th of October in the year 2020. And this is the recorded version of that. Basically, we're just going to be going over the PowerPoint in a asynchronous fashion. You guys will be, watching it at home, either if you missed it or if this is uh, sometime in the future. If that's the case, they'll let me know what happens. It'll create a paradox. So, learning objectives basically, we're going to be able to do computations with whole numbers and decimals and fractions that will include addition, subtraction, multiplication, or division. There are also other miscellaneous operations such as using exponents, but those are kind of extensions of multiplication. So students will be able to perform long division and know when to use it. Being able to use long division is nice, but how do we know when to use it? And students will be able to use the number line to determine which numbers are larger than others, and also which numbers have a higher absolute value. And we'll talk about that when we get there. And students will also have an introductory knowledge about percentages. So let's get right into operations. So I know that this is basic math, and I'm sure you all learned this in elementary school, but we're going to be going over it because it's important to think about math as kind of like a tree, and addition, subtraction, multiplication, and division are its roots, with addition being kind of like the main root, because all math is derived from that 1 plus 1 equals 2. So addition we can think of as combining other values of numbers. So 2 plus 1 is equal to 3 because we take 2 and we add another 1 to that, and we have 3 total things. And subtraction is taking away values of numbers. So the value that's to the right of the negative is going to be how much we take away from the other number. So 3 minus 1 is equal to 2. The inverse of multiplication being shown here. So when we take 1 away from 3, we get 2, and if we add 1 to 2, we get 3. So multiplication is how many times you add a number to itself. So 2 times 6, we can think of that as adding 2 to itself 6 times, or 6 to itself twice. So we get 2 plus 2 plus 2 plus 2 plus 2 is equal to 12, or 6 plus 6 is equal to 12. In division, you can, if you want to think about it in terms of addition, it's how many times you have to add a number to itself to get the first number. So in this case, the denominator of this, or what we're down here in this 25, we'd have to add it to itself twice to get 50. So 50 divided by 25 would be 2. Uh, and this works the other way. If you have 50 divided by 2, you would get 25. So operations with whole numbers with decimals. So decimals are essentially when you have a non whole number expressed as kind of like a portion. So this part after the decimal, we're saying it's 0.51 units after 2, but not quite to 3. So addition, you just need to line up the numbers so that the decimal place is in the same spot, and then you add normally as if you were adding big, like larger numbers. So in this case, we see that the 2.3 doesn't have the same amount of digits as 2.51, but we line them up with the decimal place because you wouldn't add this 2 number to the 5 because they're in different places. So we add this. This goes down since there's technically a 0 here, 8, and then 4. Subtraction, it's the same thing as addition, but the opposite. In multiplication, you basically just set the problem up like you're multiplying any number. So if this was 125 times 23, you would set it up in the same way as 1.25 times 2.3. So you would make sure that there's not a gap here at the right hand side, and then you would multiply normally by multiplying this 3 to the 5, 3 to the 2, 3 to the 1, 2 to the 5, 2 to the 2, and 2 to the 1, making sure you put a 0 here, and then you add those two results. And you need to make sure that so in this problem, we have 3 decimal places. We want to make sure that in our final answer, we move the decimal place over 3 times, and we get 2.875. And for division, we'll have to utilize long division, and we'll talk about that on the next slide. So long division is essentially a tactic when the result of the division isn't easily found. So essentially, you want to try to divide the first number, and if it doesn't work, you try to with the first two digits. So essentially, what that means, if we're looking at this one right here, we're trying to divide 1,235 by 2. So 2 doesn't go into 1 any amount of whole number times. So we're like, okay, so we go to the next number and we combine those two. So 2 divided by 12, we do get something from, or 12 divided by 2, we do get something from that, we get 6. And after we have the 6, we multiply it with this number on the outside here and write it underneath the two digits that we used. So in this case, we put the 12 underneath the 12 and we subtract those. We get a 0. And then we bring this arrow signifies that we're bringing the number down. So we're bringing this 3 down. So then this is our new number that we're working with that we have to divide. So 3 divided by 2 goes in at least once. So it would be 1.5 technically, but since we're looking at this, we're saying how many times does 3 go into 2? Once. Multiply these, get 2, 1 here, bring the 5 down. How many times does 15 go into 2? 7 times. And this process continues until you get a 0. And then once you run out of digits, you start adding zeros. So, for example, this number was just the 1,235. Once we reached this 5 here, we had to add a decimal place and a 0. And this is allowed because we're not changing the value of the whole of the number. So when we're thinking about decimals in long division, it's essentially the same thing with one major difference, and that's that we need to make this number on the outside a whole number. So in this case, the number originally was 2.1, and we moved it we had to move this decimal place over 1. And then we also had to move this decimal place over 1 also to keep the value the same. Essentially, if you want to think about this, you can think about division as a fraction. So this is technically 1.2138 divided by 2.1. So you could think about moving this decimal place over. It's kind of like multiplying it by 10 over 10, since we're moving the decimal place over 1. And you want to try to get important. I'm going to stress this again. You have to make sure that this number is a whole number to be able to do the division. It doesn't matter about this one, but any changes that you make to the decimal place, you got to keep it moving on both sides. So with fractions, you can think of fractions as a kind of like a written out division problem. So you can think of this as being saying 1 divided by 2 or 1/2. They're both the same thing. So fractions can essentially be defined as a quantity that isn't a whole number, and it's written slightly different from fractions. So instead of writing the decimal, we write it in fraction form. So, and we generally write it with two whole numbers with one over another. So we would say 12 over 7, 43 over 5, 1 over 2, and any other fractions the same way. And this 1 is the numerator of the fraction. This 2 is the denominator of that fraction. So with fractions, you can reduce them. If the numerator and the denominator share a factor, you can divide both by the factor and it will retain its value. So for this example, we have 2 over 4. Both of those numbers have a factor of 2, so we could say that it's equal to, if you divide this 2 by 2 and the 4 by 2, you get 1 over 2. So addition and subtraction with fractions, you need to make sure that the denominators are the same, or that they have like common denominators, is what you probably have heard in the past. So we need to so for this example here, we have 1 over 4 plus 2 over 5. We need to make sure that these have a common denominator. So what will work every time is if you multiply them to each other. So in this case, we multiply it by 5 over 5. The reason that we do this is because this is technically multiplying by 1. It's kind of like the opposite of factoring. So instead of dividing by a common factor, we're multiplying by a common factor to change what the fraction looks like, but not actually change the value. So here we multiply by 5 over 5. Here we multiply by 4 over 4, and we get 5 over 20 and 8 over 20. And we add those two together, we get 13 over 20 as our result. If these numbers were different, so like let's say this was a 6 right here, right? So we'd have 1 over 4 plus 2 over 6. I know you could reduce that, But if we're looking at this and we're saying, okay, what is the least number that we would have to get to? Because no one likes working with big numbers, so we want to try to keep it simple. So if we're thinking about like what 4 multiplied by different numbers turns into, we get, we can have 4 if we multiply by 1, we can have 8, or we can have 6 or 12. So then if we're thinking about 6, we can have 6 or 12. So in this case, we would multiply by 3 over 12 or 2 over 2 to get the 12 as the common denominator. But we'll take a look at that at a different point in time. So multiplication, to multiply fractions, you basically multiply the numerators and then the denominators. It's if you want to think about it, you can kind of make a line here and then multiply on the top and bottom. That's kind of what I tried to show over here. So we have 7 times 5 over 2 times 6, and we get 35 over 6. So one thing that you can do is that if one numerator of a fraction and the denominator of the other fraction share a factor, you can simplify those numbers. So in this case, I know you could reduce this to a 2, but we're just going to look at this as is. So this is a factor with this, so we can simplify this by making this 2 and this a 1 by dividing both by 5. And then we get 3 times 2, and then 1 times 5, and we get 6 over 5 as our result. So division, when dividing with fractions, basically you flip the fraction in the denominator of the bigger one. So in this case, this fraction is the numerator fraction, this one's the denominator fraction. So you flip it so that it's 7 over 5 instead of 5 over 7, and then you just multiply. And as always, you're able to simplify this. So like if this was a factor of 5, you'd be able to simplify it just like with division or with multiplication. So mixed numbers and improper fractions. So improper fractions are basically when the numerator is bigger than the denominator. So the 71 over 4 is an improper fraction. Mixed numbers are when you have both a fraction and a whole number value in how it's written. So 17 and 3/4 is a mixed number. We have 17 and 3/4. So this would be 17.75, or this would be 71 over 4 as we show over here. This is like the conversion of it. So you do operations with improper fractions like normal fractions, and to do operations with mixed numbers, it's generally easier to convert them to mixed numbers first and then do whatever or convert the mixed numbers to improper fractions and then do whatever operation you need to do. So to convert improper fractions, you need to multiply the whole number to the denominator. So in this case, 17 over 17 and 3/4, you would multiply the 17 by the 4 and then add the numerator. And then we get 71 over 4 is our proper fraction. So how to convert between fractions and decimals. To go from a fraction to a decimal, you just perform long division. And to go from decimals to fraction, you need to write the decimal as a fraction by putting it over 1, like this here. And then you multiply by 10 over 10 until the decimal is gone. So this is multiplying by 1, so that every time that we multiply by 10 over 10, the decimal place moves over 1. So we do it 2 times. We get 125 over 100, and then we need to simplify the fraction as needed. Both numbers are factorable by 25. So we do that, and we get 5 over 4 is the result of what 1.25 is written in fractional form. So really quickly, we'll talk about percentages. So percentages are essentially ratios that explain how much of a whole something is. They can also be used to convey probability. So for an example, when we did this presentation live, I did have a co-presenter with me, and she is a writing consultant, or writing tutor. And so we could say that 50% of the presenters for the live workshop were math tutors. And this is true since I am a math tutor. So this means that one is that half or 1 and 2 of the presenters are math tutors, and percentages can also be written as decimals. So you would say it's more used in statistics, but if you saw zero point 0.5 of the presenters are math tutors, yeah, it's like it's hard to explain with words, but basically you can write percentages as decimals and fractions depending, like there has to be something attached to it though. So like you would say zero point 0.5, you have like a 0.5 probability of finding a math tutor if you were to randomly pick one of the two presenters. Um, so how do we convert decimals and fractions to percentages? So essentially, to convert a fraction to a percentage, you need to first make the fraction a decimal by using long division. And then now that the fraction is a decimal, you just need to multiply the decimal by 100 until, yeah, by 100. And then so an example here, about 1 in every 10 people are left-handed. Convert this to a percentage. So we see 1 in every 10. So 1 over 10 would be the fraction that relates to that. We convert it to a decimal by using long division. I did this off on the side, but just know that 1 over 10 is equal to 0.1. So we multiply by 100, and then we get 10% of people are left-handed. So now, to finish off this presentation, we'll talk about the number line. So the number line can be used to determine how values relate to one another in terms of their value. So here we can see that 0.4 is to the left of, or 1/4 is to the left of 1/3. So we can gather that 1 over 4 is less than 1 over 3. So it's useful for determining not only the value, but also the absolute value of numbers. So the absolute value is essentially how far away it is from 0. So in this case, the absolute value of negative 2 over 3 is 2 over 3. The absolute value of 2 over 3 is also 2 over 3. So it's essentially just the positive distance it is from 0 on the number line. So this helps visualize fractional values. And this is very important, as you're able to tell kind of how fractions interact with each other in terms of their value. So in here we can see that if you have a bigger number in the denominator, you have a smaller value. So to visualize this, you can think about it in the same way as pizzas. So let's say two pizzas are the same size, so they're both 18 inches in diameter, but one is cut into 8 pieces and one is cut into 6, which will have more pizza per slice. And I think that once you think about it in that way, it becomes pretty apparent that the one with 6 will have more pizza per slice. And that's kind of how we think about it. So if we have, 2 of this 6, is that bigger than 3 of the 8 pieces? You would have to work that out, but you would eventually find out that the one with the 3 of the 8 is bigger than the 2 of 6. So you would just need to figure out what the decimal is, or you could plot them on the number line. That's another way to do it. So that is everything for the presentation number 1 of CBEST computation and numerical relationships. We're going to talk a little bit more about these concepts later, but computation mainly relates back to these operations. So if you're familiar with these operations and know how to work with them with whole numbers, fractions, decimals, mixed numbers, and proper fractions, you're solid. So thank you for listening to this recording of this presentation. I hope you have a good day and you will do great on your CBEST. Just keep studying, keep that.